Evaluate each of the following square roots: the square root of 9, the square root of 16, the negative square root of 36, the square root of negative 36, the square root of 25/81, and the negative square root of 64/49. Let's start with the square root of 9. Now, this symbol is called a square root symbol or a radical symbol. So this means a square root. It's also called a radical. And when we're asking ourselves to find the square root of a number, what we're asking ourselves is, what number can we square to get the number on the inside of the radical? The number on the inside of the radical is called the radicand. So here the radicand is 9. And so when we're trying to take the square root of 9, we're asking ourselves, what number can we square or multiply by itself to get 9? And that number is 3. So the square root of 9 equals 3. And this is because 3 squared gives us 9. 3 is the number that we can square to get 9. Now, there is actually a second number that we can square to get 9. Also, I'm going to write this off to the side. If we take negative 3 and square it, that's going to be a negative times a negative, and that will also give us a positive 9. But when we're dealing with this square root symbol, this symbol tells us that we want the positive square root. That's just the convention. So if there are two square roots, a positive number and a negative number, when we're using the square root symbol, it tells us we want the positive square root. So the square root of 9 is 3. Let's look at the next one, the square root of 16. When we're taking the square root of 16, we're asking ourselves, what number can we square, or what number can we multiply by itself to get 16? And that number is 4. And that's because 4 squared gives us 16. I'm not going to write out the reasoning for every single one, but I want to do it for the first couple, just so that if this is your first time seeing square roots, you can see where these numbers are coming from. Let's look at the next one. We've got the negative square root of 36. Earlier, I said that when we have a radical symbol, that tells us that we're looking for the positive square root. That's the convention. If we want the negative square root, we can put a negative symbol out front, and then that's telling us we want the negative square root. And here, the square root of 36, well, there's two of them, 6 and negative 6, but here we want the negative square root, so that is going to be negative 6. Very good. If we look at the next one, the square root of negative 36, we run into a problem. Because if we take a positive number and square it, like 3 squared or 4 squared, we end up with a positive result. But if we take a negative number and square it, like negative 3 squared, we also end up with a positive result. So if we square a positive number or a negative number, the result will be positive. And so it's impossible for us to get a negative number when we square something. And so we're going to say that this is undefined. There are no numbers on the number line that we can square and get a negative answer as a result. So if we're ever asked to take the square root of a negative number, we are not able to do that, and so we say that that's undefined. Just like when we were trying to divide by 0, we know that we're not allowed to divide by 0, so that's also undefined. Now, you will learn later, probably in another math class, that there is a way to take the square root of a negative number, and it involves something called an imaginary number, but that is not in the scope of this class, and so that's not something that we're going to talk about right now. Right now, we're just going to say that the square root of a negative number is undefined. Let's move on and look at the last examples. We have the square root of 25 over 81. Now, when we have the square root of a fraction, we can look at the numerators and the denominators separately. So if we look at the numerator, the square root of 25 is 5. We know that 5 times 5 is 25. And in the denominator, the square root of 81 is 9, because 9 times 9 is 81. So in this case, the square root of 25/81 is 5/9. And the reason we're allowed to do that is because when we multiply fractions, the numerators get multiplied separately from the denominators. So when we're squaring them, the numerators and denominators are squared on their own. And so when we're taking the square roots, we can take the square roots of the numerators and the denominators on their own. Now we've got one more. We've got the negative square root of 64/49. We're going to keep that negative out front because we know we want a negative answer. Now in the numerator, the square root of 64 is 8, because 8 times 8 is 64. And in the denominator, the square root of 49 is 7, because 7 times 7 is 49. And so we end up with -8/7, and that is our final answer.